Good morning, ladies and gentlemen, and welcome to our third day of Drone Enable 3. I'm very excited about this third and final day because, as you can see in the program, we have a number of very exciting and dense sessions with the operational experience panel, the high seas, stratospheric operations, the rules of the air, as well as the concluding session. So I think we're all very much looking forward to benefiting from these insightful exchanges. Before we start, I would like to provide you with a few practical reminders, especially to allow you to maximize the value that you're getting from participation in this symposium. If there's anything that you missed, another stream, for instance, yesterday that you would have liked to benefit from and that you didn't, we have you covered with our SkyLive video broadcasting that is supported by Unifly. So you can watch the Drone Enable 3 sessions on unitingaviation.com or check out the SkyLive link in the events at ICAO app. There's another benefit. If you want to connect with other attendees, you might want to try the Drone Enable 3 event app, which allows you to connect to other attendees and exhibitors during and after the event. It provides the most up-to-date agenda and will connect you with any last-minute announcements. You can download it from the Apple App Store or Google Play Store by searching for events at ICAO. I would also kindly ask you, for the smooth unraveling of the discussions today, to kindly place your phones on silent mode. So to start off today's panels, we will hear about a pair of use cases from different sides of the world that will provide lessons learned, both from an operational and regulatory perspective. The moderator for this session will be Ms. Leslie Carey, who is the chief of the RPAS section at ICAO. Please join me and welcome Ms. Leslie Carey and her panel in this session.
Thank you, Frederic. So, to get started and to give a little background on this particular panel, I had the pleasure earlier this year of getting to visit Vanuatu in order to see the regulatory development that was underway in the country and to see some of the operations that UNICEF had set up for vaccine deliveries in remote areas where there's very little road or other infrastructure. And looking at how all of this had been put together, I found it really quite fascinating. The different parties, the different stakeholders that had been engaged in order to allow the operations to occur, which started from the basis of you have to have regulations. So how do you go about developing regulations when you don't have the experience, the expertise, or just simply the basic resources internally to do this? But you want the end objective, which is the vaccines being delivered in remote areas via drone. So having looked at that whole example of what can be done, and then also coming back, and since I'm based here in Canada at ICAO, seeing what Canada is doing, which is a very, very different environment. Hence, there's snow outside here. Vanuatu is tropical and volcanic. It's just a totally different environment. Transport Canada is entirely different from the Civil Aviation Authority of Vanuatu. But there are some remarkable similarities between these two states and the challenges that they face putting together a regulatory framework and implementing those regulations in order to conduct operations. So that's the background behind this particular panel. And we'll see what kind of lessons learned, because they'll probably be similar for an awful lot of other states. So I'd like to introduce my 4 panelists, and then we'll let them give some explanation as to their roles in all of this and what they have learned, and then we'll try and get some interchange between them. So we're going to start with Mr. Jeff Graves. He was a consultant hired to evaluate the developments going on in Vanuatu, and he's going to explain those to you. He'll be followed by Ms. Catherine Gray, Katie Gray, who was instrumental in developing the regulations, and those are actually the basis of the model regulations that ICAO has put out online. Then we will hear from Mr. Mark McKeeman from Transport Canada on operations being conducted by Transport Canada here in Canada, and Mr. Felix Meunier on the framework that Transport Canada has been putting in place and how that works. So, if you would, Mr. Jeff Graves, the floor is yours.
Let me start by introducing Vanuatu for those of us, well, there's 3 of us that I know that have been to Vanuatu, so it's there. How do I? What am I not pressing?
And the stick is on the computer laptop, so.
Yeah, just bear with me a minute. What's not working?
Or Chen can advance the slides.
Yeah, so pass me the bar and I'll do it from here. There we go. Yeah, it's always the on-off button that slays me every time. So Vanuatu, middle of the Pacific, 1,500 kilometers west of Brisbane, where Katie lives, and about 2,000 kilometers north of New Zealand. The entire length of the island chain is, I think, about 800 kilometers. And there are 43 or so inhabited islands. The reason that I'm here, or the reason for the project, is that I'm going to talk about the Vanuatu drone trial, or VDT as it became known. It was funded primarily by the Australians with some internal funding from UNICEF. And one of the key parts that they wanted to do was not so much well, it was as important to learn the lessons as it was to actually inject the children. But let me move on. So that is fundamentally the things that I'd like to talk to. I should stress that I'm not UNICEF staff, because I don't want to misrepresent my position, and there are some things that I'm still not allowed to talk about, but I'm sure you all understand. So this is Vanuatu. It was the first commercial service procurement by a government for the delivery of cold chain vaccines. Cold chain vaccines, in the first year of a child's life, there are approximately 13 vaccines that children should have to boost their immunization. 4 of them need to be kept between 2 and 8 degrees. But the rest of them are fairly robust, but those 4, if they go out of the temperature range, then they become useless. It's a very valuable project. I mean, it's something that all children should have. It's a commitment on behalf of the UN and that every government has signed up to. But it's not easy. It's particularly not easy. I mean, the cold chain in Canada at the moment might be fairly easy, but the cold chain in tropical countries, particularly Africa, a little harder. And particularly remote places such as Vanuatu and the remote communities elsewhere, it's not just about the transport. There are other issues at hand that we need to address. And that was the background to the program and the reason why Innovation Exchange, that's Australian government funding, was secured to fund it. And they made a special effort for the monitoring and evaluation session so that it wasn't just a program about using drones to deliver vaccines. So when I say funded by the Innovation Exchange, in fact, everybody climbed on board. It was the Gates Foundation supported some programs, I believe part of PCADIS. The UNICEF had their own core funding. There are a lot of stakeholders and a lot of people interested in what happened, and not just internally, externally in terms of donors. For the Ministry of Health, it was pretty important. For the Ministry of Health, they also wanted to look ahead to see if whether this would be a viable solution to a problem that they had. The coverage of immunization for children in Vanuatu ranged from a good standard in the main towns of Port Vila, up in the 90%, but up in those further North Islands, it was in the 50s. I mean, there are communities there that rarely saw external doctors, rarely saw even nurses from Vanuatu. So they were quite a vulnerable population to infection, and so there was, and it is a concern of the government that that the EPI, Extended Program of Immunization, coverage rates achieved a benchmark of around 90%. Which is around the point where herd immunity starts to kick in. And it was interesting. I mean, it was like, let's not, the flying drones in tropical countries had a lot of people's attention. It certainly got, we had the luck and encouraged ICAO to come over and see how we were doing it. And it was watched by stakeholders in Africa who faced similar transportation problems, and also, I mean, it fits as a model in Australia with Aboriginal communities. So it was a fairly widespread interest. So I was sent with some terms of reference to provide advice to maximize the learning incomes and to deliver a feasibility assessment of vaccine delivery and make sure that everybody, the views of all stakeholders were taken into account. This slide is actually one of the most famous places in Vanuatu. It's called the land diving. It's the proto bungee jumping, and this guy's about to plummet, which is a bit like how I felt when I was going into this monitoring and evaluation process. But the framework that I had was an M&E system. It's my background. I have a sort of aviation background. I have a humanitarian and a development background, and also a background in monitoring and evaluation. So I was using that M&E system to put some of the rigor into the process, because otherwise I'm afraid I'd just be going around asking questions and without any structure or the robustness in my findings. And I came up with a framework that was enabled not only the comparison over time of the results, but will enable, as it goes forward, one hopes, similar programs in similar places to use the same sort of structures, so we can hopefully advance the state of the art. But this program came. It was a passion. It was a passion of one of the country directors. So it was going to happen anyway. So what I actually had to do was to go back and put some a justification back into the funding, but developing these things called log frames and problem trees, which are common in my development world, but maybe not so common elsewhere. And set the course, set the come on. Creating the high-level indicators. Like, the important thing about what we were funding was the actual injections, the change in health coverage or EPI coverage over the trial. It was a 9-week trial. The EPI coverage is measured over the course of a whole year, of the first year of a child's life. 9 weeks was not going to make a significant change in EPI coverage itself, but it would show plot a pathway to, will it make a difference? Can we reasonably project that it'll make a difference? We had a look at the project development stage. Was it a problem looking for a solution looking for a problem? I think we'll come back to that one. But and one of the issues particularly in these more rural and remote communities, has anyone here heard of the cargo cults? Yeah, cargo cults came from Vanuatu, one of the islands. It was very during the war. American soldiers would come and give spam, I think, and there was very much a remote, isolated community. The perspective that that UNICEF was worried about. They were worried that people were going to either shoot down the drones, some form of the phrase is custom or witchcraft, or because they thought their privacy was being invaded. And the other thing, the key thing to track was whether the vaccine stayed within the temperature, because if we have these drones flying around, but we don't solve the problem, we didn't really solve the problem. So the criteria that I looked at was the relevance, effectiveness, efficiency, impact, and connectedness. Connectedness means to a wider Ministry of Health and the government of Vanuatu the perspective. And those criteria are standard for every evaluation, sort of a good rubric for any M&E, the professional to use to structure their reports, and it's an OECD standard. So I came up not knowing anything about the program, just sort of brainstormed with some stakeholders in NGOs and Ministry of Health, and came up with about 40-something indicators. That's ridiculous, quite frankly. It was, but I wanted, because of the focus on the need to capture every learning, I wanted to make sure that I'd at least crack open the door to ask every question. There was some things that I asked the question and the answer was, that doesn't matter, and that's fine. But if I didn't put them down, then it was going to be a challenge to come back and ask them after the fact. Now everyone's scattered like paint, like a drop paint. All of the protagonists have left. Spoiler alert, great program. Honored to be with it. It worked. Over the 9-week trial, 17 kilos of vaccines, 586 children. The picture in the background is actually, her name was Baby Joy, and she was the first child to be vaccinated by a drone carried vaccine. I think at that particular point she's not that joyful because there's some of the injections are fairly thick needles. 55 flights, a BVLOS. We can talk about some of the salutary lessons that we learned. The two control flights into terrain, a couple of hull losses, and it was a challenge. This was about vaccination, but to be honest, at some points it felt more like midwifery, because trying to get the thing to a successful fruition was a bit hard. The importance of the report. I mean, leaving aside the actual activity, there are two levels, or multiple levels of the reporting, and there is I provide links at the end of the program. There is the UNICEF report, how great it was and how successful it was. My report was a little bit more of a management and auditing activity, like what went wrong, how could we do it better. I'm not sure if that's going to be made public, but there are some lessons that I look forward to putting out there in the public domain. And just going back to the sort of the context, some of the context of the basically why we're here. But as I see it, sort of the role of regulation is to make things, is to enable things to happen. This is possibly the best use case. It's the most valuable thing, to save a child's life, to reduce the cost of immunization, to make it within the realms of the budget of a small island nation or a underdeveloped country or even region. The best value. It's such a fine result at the end of the day, and having the regulation that makes it happen, fantastic. But being able to tell the story so that you manufacture the consent for the $8 makes it really worthwhile. So at the end of the day, the program was a success. The kids got vaccinated, and the lessons were learned about how to do it and how not to do it. The regulations were, spoiler alert, drafted. The drone providers have gone on to bigger and better things in other countries using the same technology, and I hope, undoubtedly, the lessons that they learned in how to avoid hillsides, I think, is the major lesson. I learned an awful lot about Vanuatu and drone trials and vaccinations, and I really hope that I managed to put it in my report. Thank you.
All right, thank you, Jeff. So I'd like to have Katie Gray come up and talk about the other side of what was going on in Vanuatu.
Good morning, and thank you for having me. In particular, I need to start with a sincere apology from the Director of the Civil Aviation Authority of Vanuatu, Jackie Langatti-Treef. She would love to have been here but wasn't able to, and I thank the CAV for their permission for me to talk today about this in their space, in this project. I was invited in as a technical advisor to the Vanuatu drone trials. We did it as a team of 2 to manage workload, and that turned out to be a very, very useful approach because we were able to divide and conquer in many circumstances. We were able to divide teaching CAV from regulatory development, from managing the trial, and mentoring in some circumstances with different groups. Okay, Jeff explained to you kind of where we're at with Vanuatu, but just for you, on the left-hand side are photos of the single road down Pentecost. It's an hour drive from the airport to the nurses' station where the vaccines are kept, and this is the road in the dry season when it's in its best condition. The alternative is on the right-hand side on the open ocean in the little duck boats. So it's an easy project to engage with for sure. Coming into Vanuatu, the Civil Aviation Authority of Vanuatu are certainly a resource-challenged regulatory authority. There are no backup staff, and coming into the project, they lost their flight operations inspectorate. That's one whole person, but there was the whole skill set gone. And because of the pressures on staff, there is actually no spare time. So UNICEF and the Global Fund thankfully put together and supported technical advisors coming in for the Civil Aviation Authority. They also have in Vanuatu a very high pressure to stick with the current aviation industry because they're highly economically dependent on it. So there was not a lot of comfort in the rest of the industry for them to dedicate time to a drone project. Within the project, it was BV loss, airline-style operations. This was multiple pilots, multiple aircraft being manufactured, in design, that sort of thing. Vanuatu itself is a low-technology coverage environment. Mobile phone coverage isn't guaranteed in the capital city, let alone out on any of the islands. One of the islands we went to had a hammock we were standing next to. Turns out the hammock was actually people queuing up because the hammock was where the phone coverage was, and you got 2 or 3 minutes to make your phone calls from the hammock if you needed to. Mapping also of the region is highly inadequate. Someone was talking yesterday about improving the mapping in the AIPs and the AIMs. Vanuatu doesn't even have its own solid mapping of its aerodromes, and they move. You get a good earthquake shake and they'll move by 5 metres. A good tropical season will move a runway around because it's a grass strip in its own right. But on the other hand, it's a very low volume VFR airline operating environment. There are 4 or 5 GA aircraft on the register. At the time we were there, only one was actually airworthy and flying. The rest of their industry was charter or RPT, and a small number. So consultation and stakeholder discussions were relatively easy, and we were able to use the JARIS SORA to get actually a very low risk level, because we could genuinely calculate a very low volume, low risk level. I've divided this up in terms of the drone trial itself for those interested in trials, and the regulations and how we went to the regulations, and then a bit more on lessons learned. In terms of the trial, when we got there, they didn't have regulations in yet, and the Act specifically excluded unmanned aircraft operations. So we had to go through a process of working out within their legislation how unmanned aircraft operations could be approved, and go through authorisation processes and those sorts of things. Neither operator had yet had an approval from another country that we could leverage off for the full set of operational. We took the risk-based approach, as I mentioned, with the JARIS SORA. Because we weren't sure what we had before us, we weren't sure how the operators were going. We hadn't been involved in the initial assessment, but they started out flying some minor tests and a BV loss flight in a public fora. Straight off the bat. So there was space to do that because it was such a low volume environment. We were able to tell all the operators where those BV loss flights were going to be, and they were able to go around it for the first few flights. So virtual segregation. We treated them during the operations as mini airlines, so we focused on processes, procedures, responsibilities, and outcomes, their own internal compliance type of things. We worked closely, very, very closely with air traffic control. Air traffic control expressed their primary concern was communication from the operators, and how significant and valued that was. But counterpoint, they also were very clear that lack of communication bred massive mistrust and would undermine the project. So we took the approach that they were IFR aircraft and they had to meet all the IFR requirements, and then reverse engineered back what wasn't necessary, rather than doing the VFR and add-on process. IFR approach included phone calls beforehand to advise that they were going to be doing flights, flight plans being lodged with air traffic control but also made available to all of the other operators given the small number around. Having to have the dual radios so that they could talk through and listen to 2 channels at once because they were crossing multiple radio frequencies. No TAMs being issued, but the airspace wasn't segregated specifically. And what we found was that the operators and the drones were actually doing time separation themselves. They naturally fell into it and were making way for each other. One thing I'll say is that even with the years of regulatory experience behind us, both of us as technical advisors were astounded by the cultural differences that came through. One team came from an aviation background up through and had learnt and taught themselves robotics and manufacturing. The other team came from a robotics and manufacturing background to aviation. And they were very, very different in the way that we had to approach them, talk to them, and what they focused on and what were priorities for them. As I mentioned, the risks were very low in terms of the airspace volume, but we found that at the landing sites, the risks were quite significantly higher than we'd originally estimated because people were interested. In low technology areas, to have a drone come in was fascinating, and we had crowds of people turning up for an audience. It also meant that we had roosters turning up and cows on the airfields and all these sorts of things. At one of the first landing sites, people were waving palm leaves, which was great. They welcomed the aircraft in, but that was kicking up dust, which was actually volcanic dust, and throwing volcanic dust into the engines of the aircraft, causing subsequent maintenance issues. We didn't predict that one at all. I'm not going to tell you all of the answers we came up with, but a short list of the things we had to consider during the trial was the difference between radio and GPS and telephony systems. All have their own limits, particularly in the South Pacific. GPS, if they're going to drop a satellite out and do maintenance and those sorts of things, or they've got a gap in the system, responsibly, GPS is dropped out over the South Pacific, which is the lowest use area. But that does mean that Vanuatu and those South Pacific countries actually have regular GPS dropouts, and predictable in many circumstances because they can be told the maintenance times. Signal loss then became an issue as well. What happens when the C2 link goes down? It will go down, and we were able to predict when it would go down during an aircraft flight. Then the question is, how long can that be down? What's an acceptable level of C2 link loss? 5 seconds was not an adequate limit. We were talking minutes in terms of C2 link loss. The question of what constitutes a flight. Is it landing, takeoff? Is it takeoff, delivery, return? Those sorts of things. The definition of an incident we found didn't apply. The traditional definition of an incident is not going to help the drone industry share the lessons learned because they're not feeling like they have to report an incident under current definitions. Manufacturing and component design and configuration control. These were both self-manufacturing groups with software being developed and provided as they went. So software control became an issue. Existing landing strips in Vanuatu that are closed but can still be used anyway, did they count as ones that were within the 400 feet or not? ADS-B out we tried to test. We're unable to. Technology and logistics beat us at that. But air traffic control expressed that they wanted, if ADS-B was going to be used, they wanted to see drones differently displayed on up on their screens as distinct from RPT. We did find that ground risk was, LiDAR is not the be-all and end-all, and there's not a lot of information about the forward view strength and steep incline strength of a LiDAR, and at least one aircraft suffered with that one. One of the big lessons was contingency plans when something does go wrong. there is a lot of conversation in some areas of the drone industry that the appropriate response when something goes wrong is for a drone to climb to its maximum height and return direct to its point of origin. Now, I can tell you when I heard that one, my heart sank, because that wasn't okay. And in the example that raised that, they found a mountain on their route back, and but had it happened a few minutes later, they would have actually gone straight over the top of an airfield. Equally, not okay. In terms of developing the regulations, Australia and New Zealand both influenced the South Pacific area. Vanuatu were trying to implement the New Zealand regulations, but we're having trouble certainly, in large part from lack of experience with drones themselves, but also lack of experience with the regulations. So we did quite a bit of questioning within New Zealand and CASA, New Zealand CAA and CASA, to understand their systems and where they had limits and where they felt that things could be improved. What you see on the left-hand side is us working through the logic model of what's high risk and what's low risk to separate them out. And every one of those risk shifts had to be worked through from a cultural context for Vanuatu. Is the risk higher or lower? Is the trigger point adequate and appropriate for Vanuatu as compared to Australia and New Zealand systems? Should we adjust them? Should we not adjust them? And worked through every single one of them. We trained CAV staff on the go. We utilised the drone program as the training ground as well, and challenged the CAV staff to think through all of these questions as we did it live with a group who were doing BV loss flights. It's a good way to learn in adult education programs. So we did come up with quite a few local variations. We've over there, they're delegating authority to the local police to detain an aircraft, but limited to drones, so that police can go out and if they're concerned at all, they can detain the drone or any component of the system with the authorisation of the director. The age limit for a pilot's licence, the ICAO requirements were preempted in this. The age limit was raised because the education level wasn't felt to quite match the standard 16-year-old age limit that applies in most of the rest of the world initially. We had to work through which other RPAS licences would be recognised automatically and how they would do that process, and had also implemented an exam for the RPAS licence to start bringing in RPAS law, but that couldn't be the normal aviation law exam. That was too much and too complex and irrelevant in many regards. What we did also was put all of those decisions in that risk framework into I've got them there: exemptions, authorisations, interpretations, delegations, forms, communication materials, those sorts of things, so that they weren't locked in concrete yet. So that Vanuatu has the opportunity to learn, the opportunity for their small industry to mature and change it as they get there and as they progress, as the world catches up and those sorts of things. So the last one, for the things I haven't covered yet, the lessons and things that I would like to change in what we did. In terms of the trials themselves, the risk-based approach and using the gyrosora was absolutely invaluable for us. Because there weren't regulations, we had to have something to base and justify decisions against. The technical advisors to the Civil Aviation Authority of Vanuatu, they have expressed to us that it was an incredibly useful process for them, because they were able to empower and enable their own industry and themselves in the same game of that. I would say global outreach for tenders to those technical advisors is not a perfect system yet. There are quite a lot out there, a lot of people retiring out of regulatory authorities, but the system doesn't find them all yet. Clear comms protocols or standard operating procedures for BV loss during flight are different from IFR. We need to get some SOPs into place for that sort of thing. And for bigger and BV loss type, higher risk and BV loss type flights, it's really important to have some sort of chief pilot or authorised and key personnel in place, because there's a lot of responsibility tracking through that. In terms of regulations, going through the cultural fit process was really important. A, it helped the regulator to learn what was going on because it challenged them to think about it, but B, it made it much easier to adopt and to talk to their own people and their own ministry about what was changing and why. The distinction between RPAS, being little low-to-ground aircraft that are hobby and recreational, being mini airlines or tools of the trade that are doing more risky stuff, and actually being a technology add-on to existing manned aircraft to allow the pilot to step back out of the aircraft, are three very different things. In Vanuatu, we didn't go into that third group about manned aircraft moving to unmanned space, but their regulations certainly now allow the former two. The question then behind that, though, is at what point does everyone step up from a little recreational up into a mini airline? Does airworthiness count and how much? Flight crew licensing, which members of the crew have to be licensed and those sort of thing. And delegating authority to the police force was really, really useful in terms of starting the compliance program and helping to bring the community on board, particularly in a high tourism country, where I hate to say it, the ugly Australians turn up on the cruise ships and think that they can just fly willy-nilly wherever they like and tend to start flying in the harbour where it is a flat ban. So the police can just take the drone and Australians can suck it up. In terms of regulators, the big standout was that industry actually needs to be gathering data. The entire aviation industry really is built on safety data and history of reliability, and the drone industry needs to be starting to build that as well to get further. The question I guess I have for all of you today is whether or not that sort of information can be gathered and centralised, de-identified and centralised somewhere that we can start building a bigger body of knowledge faster and do data-driven analysis behind it. I would also say with support for the smaller countries, with the low volume airspace, they are amazing places to trial things because you can get such a low risk. We got SAIL 1 and 2, the two lowest risk measures in the Jarasora in that space. It's a great space to trial things out if you want to do that and get a bit adventurous. RPAS does need to integrate into manned aviation for BV loss. Keeping them segregated is going to be fraught with challenges and insecurity, particularly for manned aviation. Oh yeah, and the other one is clarity around accidents and incidents and getting that information out to the drone industry. Air traffic control in particular is in a really good space to do that because as they start getting into radio calling and sharing information, air traffic control will be hearing about incidents and accidents, even for those that don't know they have to report, and can do the reporting for them, and that's going to help build the body of knowledge as well. I would like to just share thanks with all of these guys for sharing their photos. What you'll see there is the Civil Aviation Authority of Vanuatu with the two technical advisors. That's pretty much the entire regulatory authority. That's it, that's running the country. Thank you very much.
Thank you, Katie. All right, Mark McKeeman, please, with what's going on in Transport Canada.
Good morning. So I'm going to take a quick trip through Transport Canada's RPAS project and a little explanation about how we have achieved the things we've achieved to date. The presentation is going to be an overview of our project and our RPAS missions. So background and history for folks who don't know, Transport Canada Aircraft Services Directorate is the party that I'm with in Transport Canada, and we are a small airline inside of the regulator. We use RPAS and manned aircraft for delivering government services to other government departments. We've been around for a long time, 1936, and we are an air operator with several certificates, an air operator certificate, maintenance certificates, engineering organization, and an air training organization. Our project has two primary objectives. One is the procurement of a large RPAS for the use in supporting our national aerial surveillance program, particularly in the Arctic. And we're on pace to do an RFP process, competitive process, to acquire a large-scale RPAS by March 2022. The subject of today's conversation is more around our RPAS BVLOS missions that we've conducted to date to educate ourselves and assist our regulator in the development of BVLOS regulations. All of our BVLOS would be considered complex. We are all interested in larger aircraft above 25 kilograms in some more complex airspace environments. To date, we've completed a trial with Canada Coast Guard flying a Schiebel S-100 off the back of an icebreaker. That was our first mission in 2016. We did that with the collaboration of Canada Coast Guard, NRC, and some other government partners. And we hope to do some more work with Coast Guard in the future as they see rotary wing RPAS as a force multiplier to support their icebreaker program. We partnered with Alaska University, the University of Alaska Fairbanks, and we lease from them their Sea Hunter and their crews. Their Sea Hunter RPAS is a fixed-wing RPAS. We started with a test mission to educate ourselves on the equipment and the crews and the operation of it, and we flew a summer mission in Alma in 2017 in a test range here in Quebec. We accomplished some streaming live video. We identified vessels using the AIS transponder on the lake there, and we flew to a maximum altitude of 15,000 feet, essentially exploring the envelope of the aircraft. We returned to Alma in January to do some cold weather testing because the goal of our project is to get to the north and to get to those harsher environments. Again, with Alaska University, we flew flights in cloud, snow, some sub-zero temperatures to minus 35 C, and we validated the ice prediction system that's on the Sea Hunter, which is a temperature and humidity detector which will give us a prediction of possible icing conditions, which will allow us in the GCS to make decisions about returning home or changing altitude to avoid those conditions. There's no icing provisions, anti-icing or de-icing on the Sea Hunter platform. In 2018, we were requested to see if we could use the Sea Hunter platform to assist in some whale surveillance in the Gulf of St. Lawrence. The North Atlantic right whale is an endangered species, and they were being struck by ships and becoming entangled in fishing gear, and it was causing quite a problem. Our National Aerial Surveillance Program was providing flyover surveillance with manned aircraft, and we moved the RPAS project to Gaspé for that summer, and we executed about a 5-week mission. At that time, we flew with a 5.1 NOTAM in segregated airspace, and we implemented an artificial intelligence. Essentially, our protocol was to fly a mapping payload. We mapped the surface of the ocean. We used an AI to detect objects of interest inside those mapped photographs, and we submitted those objects of interest to marine mammal observers to identify and classify as to the type of and breed of whale. This summer, we executed a mission in Inuvik. Much more complex mission. It's 2 years in the making, and the role of this mission was to survey a new road between Inuvik and Tuktoyaktuk. It's 150 kilometers of gravel road through the Mackenzie Basin, which is a sensitive Arctic wetland. Department of Fisheries and Oceans was very concerned about how this roadway has affected the migration of marine species. There's 85 bridges, a combination of bridges and culverts along that roadway, and they wanted to get a baseline mapping of that infrastructure. While we were there, we were pulled into conversations with the Government of Northwest Territories Superintendent of Infrastructure as part of our outreach and part of our conversation. They expressed an interest in mapping the road to the south of Inuvik down to the Yukon border called the Dempster Highway. On that highway, there's at least 2 ferry crossings and about 180 to 200 kilometers of road. The southern end of it is up in a high altitude area into the mountainous area there on the Yukon border. DFO also expressed an interest for us to fly a beluga whale count in the inshore in the marine protected area to the north and to the west of Tuktoyaktuk. They fly a beluga whale mission there every year with manned aircraft, and they wanted to fly a similar payload on the RPAS, which happens to be the same payload as we were running for mapping with a lens change and an altitude change for surveillance, and compare the results of the RPAS data to the manned aircraft data. So we flew about 42 hours on that mission, 3,376 nautical miles, all BV loss. We collected a total of 80,000 high-res images. And of the 14 days we were there, or 15 days we were there, 7 flight days, 7 weather days, and 1 maintenance day. For the first time, we requested a floor to our airspace, in our blocks, and we would coordinate with Edmonton Centre, who were managing the airspace, as to which blocks north or south that we would activate for the day, depending on the weather and where we would be flying. The floor to the airspace was really important because it allowed the local traffic, a lot of helicopter traffic, a lot of reprovisioning to all of the remote communities happens during the summer, right in the middle of June when we were there. And also any survey work, any exploration work, any other type of work happens. And most of that's low level. So with a floor to our airspace of around 1,500 feet, most of that traffic could pass beneath us. There's also 2 scheduled air carriers come into Inuvik with daily flights twice a day, and larger companies doing ad hoc work, resupplying northern islands with building materials and that sort of thing. So we were able to work with the air traffic control out of Edmonton, time our arrivals and departures to not interfere with any of the commercial traffic. And we would take a second seat if we were late getting ready for a departure and we missed our slot. You know, if we didn't get out in the morning, then we'd have to wait for the noon midday flights to come in, and we'd do a flight in the afternoon. The advantage of being there in June, there's about 23 hours of daylight. Although for mapping you need to do peak sun angle, so we were flying from 8 in the morning typically till 8 in the evening. These are some of the images we were able to capture from as low as 1,500 feet there and as high as 3,000 feet. A lot of background to the technology and the size of images and the data management issues that go around that. There's a lot of work that goes into managing this kind of data. We were fortunate enough that our aircraft payload was capable of recording and holding on board all of the data for a full 8-hour mission. And that would be downloaded at the end of the mission and run through a computer. And subsequently, the GIS folks are still knitting these photos together to build the orthomosaic maps for our data products that are the deliverable to our client. That work will be done shortly. But these are a few snapshots and a few thumbnails. The ferry crossing at Sigachik, a bridge along the ITH, and a gravel pit area that was to be monitored. They were concerned about this area. I picked that image because it had some vehicles in it. Turns out they're changing a tire on a dump truck. But this gravel pit, when they had excavated a lot of gravel, the ground warmed with the sunlight and it was starting to fill with water from the bottom. So they were concerned about how that was going to affect things downstream. Remarkably, we were able to pick up all of our equipment and move it from Inuvik to Gas Bay, a total of 662 kilometers. Back and forth across the U.S. from New York to L.A. 2.5 times. We did that in 9 days so that we could be set up in Gas Bay for our summer whale mission. Again, we worked with NAVCAN to provide an airspace agreement. We worked with our task force to do the risk analysis. We utilized the JARA-SORA process to build our risk assessments and to build our redundancy. The SOAR process was the first time for us to work through it. I think it was possibly the first time for the task force as well on this complex a mission. It was a very interesting process. We did work through it, and we were able to execute as we had planned. This mission is a repeat of a previous mission, but a little bit more complex. And during this mission, we were still in the development stages of refining our AI for whale detection. In our first year, we had a difficult time getting to where the whale population was to get a lot of targets in order to train the AI. This year, we expanded our airspace so that we could assure that we could get over top of the population of whales. We were successful. We have a lot more whale idents. We collected about 38,000 images and over 175 whale images, which allowed us to train our AI. And we hope through several iterations, we're still actually doing a 100% audit of our 38,000 images to ensure that we don't have any misdetects. Where we have misdetects, we feed those back to our AI provider, and they make whatever adjustments they can to the algorithms to try and refine it even further. We had upgraded from a 25 megapixel to a 45 megapixel camera between years, which gave us the kind of density and resolution that the marine mammal observers were looking for to do not only species identification, but when they have a North Atlantic right whale ident, because of the unique characteristics of the whale, they're able to identify the whale. All of the remaining 480 or so North Atlantic right whales are identified by individual. So we were able to accomplish 72 and a half hours of BVLOS flight, 5,800 nautical miles covered, as I said, 38,000 high-res images. We were 28 days on site with 14 flight days, 11 weather days, and 3 days of maintenance. Over the course of this year, we put a significant number of hours on this airframe, more than any other operator of this airframe. And when you put that many hours on an airframe in a real live situation, you start to find the weak points. So there were several areas where we have concerns, particularly in the fuel system, fuel management, fuel indication. We had some issues with fuel pumps. We had some issues with fuel transfer. We had to return to base early. We had some difficulties in that way. So we're going through a thorough analysis and SMS review of the equipment and procedures around that incident, and we're using that to educate us for next year's operation, but also to drive some modifications to the airframe. We also had some just outright snags. We had an ADS-B and transponder failure, so we had to upgrade that, replace the components. And we had some autopilot programming issues which were a contributing factor to a hard landing incident which required some maintenance on the aircraft. I have to say that even with all of those difficulties, our regulator, our task force, and our NAVCAN airspace people were working with us, and we were able to recover from all of those things to get back into a flight status and make the best use of the planned mission. That's appreciated. The other thing is managing with C2 loss, or C2 link. We use Iridium satellite for our C2 link. That C2 link has actually a better coverage in Inuvik because of a confluence of satellite coverage there than it does in Gaspé. In Gaspé, we found that with our experience from last year, trending into this year, we were able to negotiate a protocol and an airspace agreement understanding to avoid any C2 loss calls that were superfluous. I mean, sometimes you have lost comms, lost links where it reconnects within a very short period of time. We were able to manage our agreement such that during the course of this season, we had only one incident where we had to report a pending lost link, which had recovered before the phone call was over. So we were quite happy with that. But people have to be aware that using Iridium and C2, you will need to have some sort of lost link redundancy and procedures around that. These are some of the whale images we were able to capture. The interesting thing here is that this year with the refinements in our AI, we're actually able to capture whales subsurface. They don't have to break the water to give us an AI target. The left-hand photo is a North Atlantic right whale. The other photos, I believe, are fin whales, and these pictures are taken at altitudes of 2,000 and up to 4,000 feet. So we're able to operate at much higher altitudes than the manned aircraft for their surveillance, again with a floor to our airspace, and so that manned aircraft could operate and function below our airspace. Now, we displaced horizontally and we displaced in time, so we didn't do concurrent operations one above the other, but you know, it allowed them to work in the same area without having to ask for clearance into the NOTAMed airspace. So to date, we've done 181 flight hours, all BVLOS, almost 14,500 nautical miles, 130,000 images. Our longest flight from the ground station, 110 nautical miles in Inuvik when we're flying up in Baffin Bay. Our longest mission with the C-Hunter 9.7 hours. We're refining our AI algorithm for the North Atlantic right whale mission surveillance, and our next steps there is to try and get that AI processing on board the aircraft. Right now, all of our processing is done post-flight. We've been able to contribute with lessons learned to the BVLOS regulatory development. And at this point, Transport Canada Aircraft Services is one of the leads in the BVLOS space here in Canada. We're flying some missions that have yet to be met by the private sector. So the challenges we have are budgets. Budgets are always a challenge, so budgets for acquisition. We're moving forward with the budget that's been allotted, and we'll see how that goes when we get to a competitive process. The development and implementation of regulations is key to unlocking the commercial and economic benefits of RPAS. At this time, our BVLOS missions are considered one of, requiring an extensive planning and extensive planning and risk assessment process with our partners at NAV Canada and Transport Canada Task Force. The use of 5.1 airspace, well, it's a tool that we can use now. We definitely want to move away from that. We need to know what is required to integrate as opposed to segregate. So we're working towards those sorts of things with potentially some trials in the future. RPAS traffic management is something that's coming downstream, and we need to know how our operations will fit into that framework. And there are challenges with the RPAS platform build quality systems redundancy. Without a fixed standard, various platforms will come to the market with various levels of redundancy and reliability. We need a way to assess that, manage that, and normalize that status. And that's it for me. Thank you.
All right, so we've gone from tropical island to Arctic. A bit of a change. But now, Felix Meunier, if you would finish off, please.
Thank you, Leslie. The first thing maybe before I go here is that for people who are used to this building here, people know that Transport Canada tabled a paper at the ANC a year ago or so, and from a terminology standpoint, we use RPAS, I guess, for all types of UASs. So we like a gender-neutral terminology. So if I use RPAS, just bear in mind it may mean something else in your jurisdiction here. So I'm Felix Meunier. I'm from the RPAS Task Force. So we're the regulator, and we give the waivers, the SFOCs to Mark. And the setup we've got is that we've got a dedicated multidisciplinary task force to address the emergence of RPAS in this country. So people may already know that we got our VLOS regs out earlier this year. It's up and running. It's through an administered and online portal. So that's all and well. But now this leads us to changing gears and moving maybe towards a BVLOS approach here, which forces us to have an increased dialogue with new players, new kids on the block. We have our little R&D unit to help us inform and develop our standards internally. We're running pilot projects. Mark is one of them, but I'll go into a bit more details. And this BVLOS approach just forces us to have better international engagement, including ICAO, to ensure that we've got an international harmonized type of framework that works for everybody. So what is Canada here? We've got unique geographic characteristics here. And of course, people would have noticed that we've got miserable weather. We're pretty good at that. But we've got very isolated areas, low population densities. For people to know here, I mean, 90% of the Canadian population within 100 kilometers of the U.S. border. So as soon as you're 101 kilometer and north, you've got a very, very low population. But you've got population, and if you go up north, you've got remote communities, you've got Aboriginal communities, you've got a lot of natural resources sector up north. So there's a lot of use cases for these type of activities there. Wildlife monitoring is one of them. Linear surveys is the other one. But so I think we have to first responders. So we have to look at this in terms of what makes sense for Canada. And I've heard the Rwanda minister make a very compelling case for what makes sense for his country. I think Kathy and Jeff talked very highly of what makes sense for Vanuatu. I think Lorenzo yesterday explained well what makes sense for Switzerland. So I think each country has to find what makes sense for us. And if we are to do drone for good, what do we have to work out that makes sense and we can get a social license from our population to support this emerging technology. So if I talk a bit about what we want to do on BVLOS in Canada here. So we've got the two test ranges. Mark talked about the one in Alma, which is about 600 kilometer, maybe 500 kilometer northeast of here. So these are class F airspace that we've got reserved for R&D activities related to RPAS. The pilot projects I've got listed there. So one of them is the missions that Mark talked about, and the other three there. One is Canada Post, our postal delivery services in Canada, which is a Crown corporation testing some deliveries in Western Canada. Drone Delivery Canada is a company who tried some deliveries in Aboriginal communities in Northern Ontario. And Ken UAVs did some linear surveys of pipelines in Northern Alberta. So you can see the diversity of use cases right there. So we want to understand these trials. At the same, we don't have a fulsome reg framework yet. So what can we do in the time being? So this is where we are in the green category there. We think we can do some interim measures to allow some routine BVLOS operations with safety mitigations where it makes sense, when there's a public interest case and when the risk is pretty low. So what we've got at the bottom there, so we allow BVLOS, routine BVLOS operation in a couple instances. If you are familiar with the Jarosora, these are AECs 10 and 12, but we are using the Jarosora exactly how, as an international harmonized tool. But you would say, how much is AEC 10 and 12 in Canada? It was actually quite a bit of airspace here. And maybe before I bring the map in, maybe I'll just put a comment here about AEC 10 and 12, isolated airspace and atypical isolated areas, atypical airspace. It gives us a lot of opportunities, lots of use cases, but at the same time, as regulators, you cannot have hundreds and thousands of use cases here. We don't want to use a cookie cutter approach, but at the same time, you need to make sure it's cookies that you get out of this. If you get lettuce, I mean, at some point you cannot, as a regulator, administer one off after the other. So it needs to be as systematic as possible. Put the bar reasonably high so the serious people can make it through, but at the same time, you don't want, you want a certain systematic approach, because the risk of this is that you become overwhelmed as a regulator, and then at that point, nobody can get through. So I think we find a balance there that makes sense, allowing people to do it safely, but at the same time, not stifling innovation. So it's very easy for me to say that, but when you put it to implement, it gets more tricky. And that's why that dialogue with the industry is critical, but that dialogue with your local stakeholders, with the communities, to understand what makes sense for them, because that may facilitate the implementation quite a bit if you do it carefully. So this is a map of Canada here. So I've put in blue what is our controlled airspace from ground up. So you can see we have controlled airspace in Canada, but you really have to look hard here to find these things. And as soon as you're a bit above the U.S. border, there's all types of wealth opportunities that are out there. But you say, but Felix, if there's nobody there, what can we do? Well, you can do a lot here, because all the natural resources extraction sector is a bit further north. As I've noted, we've got remote communities in Canada. It's very, if you came here to Montreal, you see this is a thriving city, my home city. But you've got remote communities up north, which are fascinating communities, Aboriginal communities that are connected only by with a couple ships per summer, and during the rest of the year they've got to rely on some kind of air bridge to have essential goods making to these communities. So there's a strong case for some deliveries in those communities that would make sense if we can find the right operations and the right business case for these type of communities. Our electricity is largely generated up north, so this means high tension power lines, 735 kilovolts coming down from areas around the 55th to 60th parallel, making its way down with no roads next to these power lines. So right now these power lines are surveyed by low-level helicopter operations that carry safety risk, obviously. Lots of opportunities for drone surveys there. And the natural extraction sector in terms of surveying and inspections as well. One thing I do agree with Mark quite heartfully is that these no time of 5.1s here for operations. It works for now. It's not the way of the future. We cannot sustain this. This is from our perspective, on philosophical grounds, airspace is a public good, and I think it's all up to us to protect equity in access to the airspace. So the 5.1 blocks a large chunk of airspace, which then becomes not possible for others to access. So if I can conclude here, I've put a little equation because I'm background in engineering and I love equations. So Canada, we've got a unique formula to permit BVLOS operations. So as you know, it's a vast country, but largely isolated also in some respect. I've put developed economy there. That has its own, what I mean by that is that we've got a very strong aerospace sector, have that for many years. I would also argue that aviation largely is what developed this country and connected this country from west to east and into our northern communities as well. And that has its own opportunity for drones as well. I think we've got diverse use cases. I could have had challenges in terms of weather as well. If you can make it happen in Canada, you can make it happen everywhere, I would say. And we've got, our legislation is actually reasonably flexible. And this allows us, based on safety grounds, to allow a lot of operations. So the next steps we're doing on our side is that we'll consider additional trials, I think as Mark noted, but with specific focus on deploying the deployment of RPAS, traffic management, what we call RTM in Canada. Lorenzo made a couple of references to what makes sense for Switzerland. I think Canada has its own use cases that would make sense for us to look at. So we'll vice chair the JARUS and host the 2020 plenary meetings. We're very happy with for that, for those who were in Chengdu 3-4 weeks ago. And we've committed to initiate consultation, pre-published rules for lower risk BVLOS operations in 2020 with a pre-publication in winter 2021. So maybe if I can leave one thought from a social license perspective, which I think as regulators we should always kind of be mindful of, because these are the citizens and the public we serve, and I think we have to protect the public interest test here. And in Canada, we've tried to support first responders' activities on for BVLOS. We tried to support Mark in terms of his exploration and NASP and surveillance activities for mammals. So if we can demonstrate to our populations that that they are really drones for good activities, I think this facilitates our job quite a bit, because the consultation becomes easier, the interaction with the population becomes easier, and the access for employment for some of those people becomes easier as well. So I think this is something that from a social license perspective may not exactly be part of our guidance material and this and that, but as an implementation tool, I think it becomes very practical. So I want to thank Leslie for inviting me and my colleagues.
All right, thank you. We actually do have a few questions, and we'll just take a couple of them quickly. We do have coffee that is waiting for us. So one question first. If you could explain, Felix or Mark, 5.1.
Okay. This is what we actually refer to as a NOTAM 5.1, i.e. This is NOTAM that we publish in coordination with our ANSP, which is NAPCAN, which is a private, not-for-profit, non-share capital organization. And this basically blocks off a chunk of operations and in effect creates a very large bubble around an operation. So it's a bit what I mean in terms of it works when you've got a trial. It cannot be a routine thing, because if you're a GA pilot looking to fly somewhere there, you publish, you pull your NOTAMs, and then you've got 99 or 150 of them, and that sometimes becomes difficult to follow through. So it is, if I can put in one sentence, just blocking a chunk of airspace, and it goes against, I think, what ICAO wants to integration versus segregation. That's the weakness of the 5.1.
All right, very good. Because I know there were quite a few of us that were 5.1. Okay, is that segregated airspace or just what exactly?
You have to have fun in your overnight to read the Aeronautics Act to appreciate how entertaining that could be. So make sure not to read that 5-point article in our legislation.
Well, I'm going to do a little modification of a question here because it still relates back to the 5.1 airspace. But I was wondering if, since you were working with the University of Alaska, were there any flights that were crossing between Canadian-controlled versus U.S.-controlled, or including offshore airspace in the Arctic?
No. During these missions, we all conducted all of our flights in Canadian airspace under our Canadian agreements and our Canadian authorities. We have entertained potentially sometime in the future a cross-border flight as a proof case, another use case, and we may track down that way at some point.
Good, I'd like to see that. Personally, having been an air traffic controller in Alaska, I think that's a great thing to do.
We're already halfway there. Your aircraft, Mark, was an N-registered aircraft, right? So technically speaking, we've made some headways, Leslie.
All right, in terms of the drone operations in Vanuatu, so to Katie in particular, what kind of mechanism was implemented, particularly in terms of the oversight of those operations? And how could that experience that was obtained be shared with other states?
Good question. I tried to stick with air traffic control. Initially, the oversight was direct. We actually had either CAV or a technical advisor sitting in the remote cockpit with the pilots doing direct oversight for at least 5 flights while they settled in and proved that they were successful in that regard. Once they were released from direct oversight in the cockpit, they were required to expose their flights and make them available live over the internet, so that at any time and during every flight, if need be, CAV could tune in and watch how the flight was going. And they had to have mobile phone access the whole time, so that CAV, if they wanted to, could ring them and talk to them right through a flight or before or after if need be. And obviously CAV were tuned into the radio and talking to air traffic control during that time. The further along they got, the less frequently CAV were tuning into those sorts of things, particularly when it got to repeat flights and that sort of stuff. But certainly the first one of every route was tuned into every time.
All right, and for Jeff, so in terms of the having operations for social good, humanitarian operations that were being implemented in one state, Vanuatu, but the lessons learned from setting up those humanitarian social good operations, because we certainly know that these are being attempted in multiple states where they can do a lot of social good. Yeah. So what are the lessons learned that can be brought to other states and other entities who are trying to set these up?
Another good question, and in multiple dimensions. I mean, there's on the technical level, I think it's fairly clear that bidirectional payloads are useful. We had 2 examples. One would lower a box containing the vaccines and then fly back, and the other one would stop, land, a nurse would come out, take the vaccines out of the top, and then be able to replace things to go back again. A particular case in point, on one island, they're all long, thin, volcanic islands. There were the malaria vaccines come in a 5-pack. Then there was one pack on the island. 2 of them had been used in a remote community called Burma up on the north. There was a case of potential malaria down in the south, using the bidirectional capacity of the drone. It went up. It picked up the 2 spare ones from Burma and took them all the way down to the other end of the island, which would have cost about, I'm going to say, $250 and about 2 days of solid travel. and it was done in 80 minutes for a marginal cost of about $10. So that's one thing that, from now on, anybody who proposes a one-way trip with a drone is not at the state of the art. The second thing I think that we is on a more operational level. It's fairly clear sort of the cost structure of a drone operation. There's an awful lot in setting up, particularly in going to remote islands. The transport of batteries is a particular problem, and nearly sank one of the operators because they couldn't get their batteries from Germany through Australia to Port Vila. The other operational issues, it's fairly clear that you need aviation perspective in the operators. The two examples that Katie gave were the people who came from a model aircraft and a robotics perspective into what's essentially a cargo air operations struggled. The expressions on their faces when we were talking about IFR operations of blank astonishment and that they now had to, for want of a better word, play with the big boys, was fairly scary, I think. And so to go back to the cost structure thing, it's hard to get them started, but once you're started, it's really cheap. Particularly, in an area that's transportationally challenged.
All right, are there any final comments that any of you would like to share on lessons learned from your experiences that can be made use of by other operators and other civil aviation authorities in setting up operations? We'll just go quickly down the line here. Felix?
Something I think has been very helpful for us is to start reasonably small with something you can succeed and then scale up. And if that's something we're trying on our BV loss regulations here. We've got lots of ask in the Canadian industry saying, can I have a BV loss regs that covers urban air mobility and that covers pretty much everything you can think of? I think the challenge with this, if you go too big, too quick, is that you got a high risk of failure here. So we took a different approach here in terms of, as I've noted, to trial, start small with a success, and then scale up. So we think this is something that has a higher level of support within the population. We can deliver, we can show, demonstrate success, and then after that, you build the social license to allow you to go further. So I think if we go too quick, too fast on stuff that's unproven, that's where you carry risk that may actually slow down the long-term progress of the industry.
So I think for us, we've taken a crawl, a walk, run approach. We started small with an offshore mission, very simple airspace. We went to a couple of trials. We moved to a surveillance mission, and then we moved on to some more complex mapping and a rejig of the surveillance mission with a larger airspace. Our end goal, of course, is complex BV loss missions, and I think we're here early enough working with the regulator to try and build that body of knowledge so that when we get to that point where those kinds of regulations are ready to be built, we'll have had a fairly decent background and exploratory effort into all of the sorts of things that we may have to deal with. So we look at ourselves as building that framework that's going to open things up downstream for a commercial or pass industry in the BV loss space that will be economically viable and within a regulatory framework that can work.
And we still get along.
Yeah,
for me, I think the value is, I'm sorry, that's fascinating. Like to be able to see a whale from 4,000 feet, we don't tell the story. We don't make a case. We don't do it in a structured way. We don't do it, I don't see it often enough that we have a rigorous, structured way of looking at our PAS operations and what good the good part of Drones for Good. I come from a humanitarian medical background. I think it's great to be able to vaccinate children for taking the cost per child from, I think it's $22 a child was the transportation cost in Vanuatu before we started, and now we've shown the potential to bring it right down. That's fantastic. We don't celebrate it enough, and we don't do it enough in a structured way. And being able to count all 436 right whales and name them, that's fantastic.
We didn't do that, but we're spotting them.
Okay. And to be able to celebrate that makes the regulation thing enables this, and we need to make a better case of it. Take it away, Katie.
You should have finished on that one. I think for me, the standout was the space in software. I know manned aviation are a bit challenged on this at the moment as well, but within the drone space, the software is open at the moment, and we don't have a handle on that. What are our expectations? What are the limitations and those sorts of things? And I think there's a good opportunity in RPAS to really step up and look at software as its own expertise in its own space, and perhaps lead that for the manned aircraft.
All right, very good. Thank you. So that brings us to the end of this discussion. So if you would all help me thank this panel for sharing their experiences.
Thank you very much for this very insightful session and these gold nuggets of real-life practical experience. We would like to thank Airbus for sponsoring this morning's coffee break, and for everyone in attendance or for online participants. We would like to remind you that we'll start the next session at 10:50. I would like to request that the speakers for the next session be on stage at 10:45. Thank you very much.